Hello! This is our experiment on the effects of gravitropism on the Vigna Radiata by Daisy Aguilar, Karen Boyce, Uriel Chavez, Alan Mock, and Tracy Talton.
Background. Plants need to grow upright in order for their leaves to efficiently perform photosynthesis, and for their root systems to angle downwards to reach necessary water and minerals for photosynthesis. To achieve this, plants emit auxin hormones from their apical meristem through auxin efflux pumps. This hormone is released on the lower side of the roots and stems, where it is affected by gravity. In the shoots, auxin is used to promote cell elongation so that they are encouraged to grow up. In the roots, auxin is used to inhibit cell elongation so that they are encouraged to grow downwards. Aim, research question, and hypothesis. Our aim was to explore the effect of gravitropism on the shoots of the Vigna radiata. Our research question is, what effects does the angle of the Vigna radiata have on the angle of its shoots? Hypothesis. If the Vigna radiata were to be grown at 32 degrees incline, its shoots will grow at 32 degrees in the opposite direction because the auxin in the apical meristem will promote elongation along the bottom of its shoots and negate the incline.
The independent variable of this experiment will be the group grown at a 30-degree incline. The control group will be the ones not grown at any incline at all, and the dependent variable will be the angle the shoots of the plants grow in. For the constants, the species of plant that will be used is Vigna radiata or mung beans. The quantity of water used for each plant will be 5 milliliters of water per day. The soil used will be Miracle-Gro moisture control potting mix. Quantity of soil for each plant will be 80 milliliters. The time exposed to light for each plant will be 24 hours, and the light bulb used will be Helloify BR30 LED Plant Grow Light Bulb 9 watts. The ambient temperature of the experiment is assumed to be at 21.67 degrees Celsius because the thermostat in the testing room reads and is maintained at 21.67 degrees Celsius. Another assumption is that the direction of light is assumed to be constant by diffusing the light with white panels, thereby reducing any bias the direction of light will have on the growth of shoots.
The ethics of our experiment go over the disposal, and the plants will be mulched once the experiment has been concluded, and any leftover materials will be recycled or reused. It also goes over our energy and the electricity used, which is sourced from a solar farm. That means that there is no excess of carbon released into the atmosphere through this experiment.
As for observations, all seeds were roughly the same color of dark green, and no seed was significantly brown. None of the seed coats were compromised in any way, and all of the seeds were 4 to 5 millimeters in length. The equipment used were 40 Vigna radiata seeds, 1.6 liters of distilled water, 43-ounce plastic cups, Miracle-Gro moisture control potting mix, approximately 1,600 grams, a protractor, a ruler with at least centimeter precision and is 90 centimeters long, the Helloify BR30 LED Plant Grow Light Bulb 9 watts, large white panels enough to surround the testing environment, a cup with milliliter precision and can measure at least 5 milliliters, a container large enough to house 40 seeds, and paper towels. Procedure 1. In order to germinate the seeds, wrap the seeds in a fully soaked paper towel and allow them to rest or germinate for 24 hours. With the 43-ounce cups, place approximately 40 grams of soil in each, with 20 of them also being leaned on a 32-degree incline, which will be the experimental group. 3. Once the seeds have germinated, plant each seed in separate cups at the center of each cup and 1 centimeter below the surface, using the ruler. 4. Fix the grow light 90 centimeters above the plants, angled directly downwards, then place the white panels surrounding the plants to diffuse the light. 5. Water each plant 5 milliliters of water each day and continue for 8 days until the experiment has concluded. After 8 days, place a protractor level to the soil of each plant and measure the angle between the base of each plant to its shoot apex, and record the angle of each plant.
So here starts the data analysis, and we used a t-test. The t-test was chosen because this is the most effective for analyzing whether there's a significant effect between the independent variable and dependent variable, aka the control group and the experimental group. Our null hypothesis is the angle Vigna radiata is grown at has no effect on the angle of the shoot growth, and our alternative hypothesis is that there is a significant difference between the angle of the shoots of the Vigna radiata. This is our formula and equation for the group variance, and this is also the equation for our t-test score. And there is a difference between the means of the values for each group, and that is 8.93. It is calculated to be 2.84 for the group variance. And for our t-test score, it was calculated to be 3.1, and the p-value is calculated to be 0.01, meaning that the groups were different. Here's our raw data, which is the inclination measured at degrees and angle of growth also measured at degrees. The 0 is our control group, and the 32 is our experimental group. And those are the angles of growth for each. For our analysis conclusion, the research question that was chosen to do this analysis was, what effect does the angle of growth have on the shoots of the Vigna radiata? And based on the analysis and data that was concluded, the analysis can be concluded that the angle of the growth greatly affected the two groups of the Vigna radiata and their shoots, and the groups are completely different. This is the calculated mean for each group and the calculated standard deviation. This is the annotated graph. This is the final graph showing our angle of growth and the inclination and how they were measured. This also shows our standard error of the mean, the groups, and the standard deviation. This is also what lets us know for the proof that there is a significant difference between the group values, as the t-test shows before, as well as the p-value.
To wrap up the conclusion and connection to the podcast, concluding the experiment, it believed to the found from this experiment that it does not support the null hypothesis because of the test value were greater than 2. Meaning there is a significant difference between the control and the experimental group, while it's proven true for the original hypothesis. For your information, the original hypothesis is the alternate hypothesis. One of the p-value were calculated as 0.01, stating that the group is different, and what makes it believe the original hypothesis, thinking there wasn't going to be a different result. Now, for the analyzing conclusion, is also explained that data graph shows that one of the plants and their shoot difference, since that's how the alternate hypothesis or the original hypothesis became true. One of the connections to the podcast to our experiment, that Smarty Plant explained how the plants intended to grow the amount of water, oxygen, sunlight, or maybe heat too for the sunlight in the environmental area, while our experiment was to research and calculate the angle and by using the water, temperature, and the heat as well. Lastly, for the Tree to Shiny Tree secondary podcast, has shares the similarity with null and alternate hypothesis for our experiment, while the podcast argue if it's true or claim to be false for their own hypothesis. For the strength and the weakness to our experiment, one of its strength was the plant intended to grow at a different angle, but the growth time for sprouts seems to be increasingly fast, which usually in my research, it will usually grow around 1 to 3 days, depending how well you're taking care of the plants and bunch of the different varieties to the plants. Now, for their weakness, the growth time are usually 90 to 120 days, or from beginning of the sprout, if you want to complete the plant and turn them into the mum bean, and have all the nutrition and everything being ready, to use it. Now, for the phylogeny, This was very helpful for the background information and getting started on the conclusion. And you can check them out in the link description below for the video, or check it out on the Google slide via Schoology.
And here is our bibliography.